Hello there, welcome to my question of the day. This is number 16 in a series that I've been running since the beginning of September. And this question is designed to be done by pupils in year 12 or 13 who are studying for their maths A-level, but really anyone can have a go. So I've been asked which of the following expressions gives the exact number of seconds in the last 6 complete weeks of 2007. I do think the year is actually a bit of a red herring in this question. I think really we've got to convert 6 complete weeks into seconds. And it asks you to write it in factorial notation. Just to surmise there, if you had 3 factorial, for example, 3 exclamation mark, that would mean 1 multiplied by 2 multiplied by 3. I prefer to say 3 times 2 times 1. So if I had 4 factorial, it would be 4 times 3 times 2 times 1, etc. So anyway, I've got to find 6 weeks in seconds. So I'm going to start with 6 weeks. Now I know that if I multiply that by 7, I'm going to end up with getting 6 multiplied by 7 as the number of days. If I multiply that by 24, I'm going to get the number of hours. So 6 multiplied by 7 multiplied by 24 is the number of hours in 6 weeks. I'm going to multiply that by 60 because of course there's 60 minutes in each hour. So I've got 6 multiplied by 7 multiplied by 24 multiplied by 60, and that's going to give me minutes. And this is great for practicing conversions. I'm going to multiply by 60 again, and that will turn my answer into seconds. Right, so there we have it. There is my number of seconds. And somehow I've got to rewrite that as one of those factorial expressions. Now this gets me quite excited because when I see a product, I think of the fundamental theorem of arithmetic, which says that for every composite number, a number which is not prime, you can always write it or express it as a product of its prime factors. So just because this really excites me, I'm going to do that for every single number I can see. The number of seconds I'm going to express as, well, we might as well put 1 multiplied by 6 multiplied by 7 multiplied by 24 multiplied by 60 multiplied by 60. And for each one of those numbers that is non-prime, i.e. composite, I'm going to express it as a product of its prime factors. 6 is 2 times 3. So I'm just going to write that underneath. Imagine there's a multiplication sign there. I've got the number 24, which is 3 times 8. You can do it like that. I always prefer to do it like this, really. Just really having 3 branches. I just prefer to do it like this. Personal preference. There's lots of ways to get the product. And 2 times 2 times 2 times 3. And then the last one I've got to get is 60. 60 is 6 times 10. 6 is 3 times 2. 10 is 2 times 5. And as long as I'm breaking them down as their prime factors at the end of each branch, it really doesn't matter the order that you do it. 2 times 2 times 3 times 5. Okay, so I'm now in a position where I can convert the number of seconds to the prime factorizations. So I've got 1 multiplied by 6. Instead of writing 6, I'm going to write 2 times 3. I've got 7. Instead of writing 24, I'm going to write 2 times 2 times 2 times 3. Instead of writing 60, I'm going to write 2 times 2 times 3 times 5. I've got to multiply by another 60 again. I don't really need the brackets in, but I'm just showing you where these expressions come from, really, if you refer to my lines of working. So what I need to do in order to express it as a factorial is write it as 1 times 2 times 3 times 4 times 5, etc., until I get up to the biggest number that I can. So I've got my 1, I can see a 2 times a 3 sitting right in front of me, so I'm going to tick those off. I'm going to multiply by 4, well, I know a 2 times 2 is 4. Somewhere I can spot a 5, multiplied by 6, 2 times 3 is 6, multiplied by 7, I can see a 7. Multiplied by 8, well I know that 8 is 2 cubed, so 2 times 2 and another 2 there. multiplied by 9. So I should be able to find a 3 and a 3. And finally, multiplied by 10. I've got that 2 and the 5 left over. That is 10 factorial. And therefore, if I go back up, yes, it was the answer B. You're probably wondering why I took such a long, circuitous route in order to answer that question. And the fact is, I just really like prime factorizations. You didn't have to do it like that at all. There were a number of ways you could have approached that problem, but for me, I just really enjoy that method. Thanks very much for listening. If you want to leave a comment below, you can, or go and visit my Facebook page if you wish to do so. Thanks very much indeed. Bye-bye.